All right, we're going to do a little quiz. We're going to do a physics for martial arts quiz. Now, I was prompted to do this because a video came up in my YouTube feed the other day, and it actually discussed some of these points. And now, if you look back at our first two videos in the Physics for Martial Arts video series, you'll see that a lot of these topics are covered in detail. We're just going to go over it quickly. I want to see what you guys remember, and we're going to discuss another concept. We're going to discuss one of those concepts, rather, that was already previously discussed briefly in just a little bit more detail. So let's do the quiz first. Here's the first question. True or false? Because F equals ma, remember that's Newton's second law, because force equals mass times acceleration. If you increase mass and you increase acceleration, your force will increase and be equal to the product of mass and acceleration. So that's the first one. True or false? Basically, because F equals ma, if you increase these two things, does the force that you can deliver to your opponent increase, and is it equal to this equation? Question one. Question two, another really common topic. If you retract your punch faster, thereby decreasing the duration of impact, does it increase the impact force? Important concept, important physical principle. Okay, so does retraction of a punch, the speed of retraction and the time or the duration of impact, affect the overall impact force? Also, what is borrowed force? And based on your definition, when is it and when is it not applicable? All right, so I'm going to give you a couple minutes. Write down your answers. I'm going to give you a couple minutes to work on it on your own, and then we're going to take a couple minutes, and I want you guys to discuss it a little bit to see what everyone else is thinking. Okay? And then we'll come back and we'll talk about it as a group, and we'll go through the answers one by one. We're going to go through the answers in a second, but before we do, I want to quickly outline Newton's three laws of motion. So let's come over here for a second. So law number one says that an object in motion tends to remain in motion, and an object at rest tends to remain at rest unless acted upon by a net external force. So what does that mean? Well, it means if you're moving, you want to actually remain moving. If you're not moving, you want to remain not moving, and force is what's required to cause a change of motion. I mean, that's what that's saying, okay? And that's actually, law number two is basically the mathematical representation of this. It takes a net force. Right now, I'm not moving. There's force pushing up on me, and I'm pushing down on the floor. The floor is pushing up on me. Gravity's pulling down on me. Okay? So there's two forces at play on me right now. Gravity's pulling down. The floor is pushing up. But they're in balance, so I'm not going to move. Thankfully, they're in balance. I'm not falling through the floor. So it takes a net force, an imbalance in force, to cause a change in motion or an acceleration. And then the last law, for every action, there is an equal but opposite reaction. Meaning, if you have the force of me on the ground, then the force of the ground on me is equal but opposite. Okay? For every force, there's an equal and opposite force. So those are the three laws of motion. We kind of need an understanding of this to answer some of these questions. So, question number one, true or false? Because F equals ma, increasing these two quantities will increase the force you can deliver, and the force you deliver is equal to this. Now, I heard somebody say true. That's false. Because what we just learned is this isn't the force that we are delivering, it's the force that's acting on us, causing us to accelerate. And this was the topic I just saw. And the equation was cited yet again. Very often this equation is used to explain why you should accelerate, and it's misunderstood. Okay? You do want more mass, and you do want that mass accelerating. But that mass is not equal to the force you're going to deliver. The reason you want more mass, and you want more mass accelerating as fast as possible, is because if you increase your momentum, which is your mass and your velocity, greater momentum is going to increase your impact force. Greater acceleration is going to allow you to get a greater velocity and therefore an overall greater momentum. Okay, so false. Don't cite this equation as the reason that your force is greater. It does play a role. it is involved in this. We're not going to go through that again, though. You can review your notes or look at, I think, the first Physics for Martial Arts video. Question number 2. This one I'm just going to briefly go over. It has a much more detailed explanation. So if you retract your punch faster, thereby decreasing the duration of impact, does it increase the impact force? Who says yes? Who says no? Good. It does not. Might it have an effect on the nature of the impact force, the nature of the impact, rather, felt? Yeah, it could. However, it is not going to increase the impact force. It's not going to increase it. Okay? I'm not going to go back through the detailed explanation there. If you don't remember, again, that's the second Physics for Martial Arts video. The last question, this one we're going to spend a little bit more time on. What is borrowed force, and when is it not applicable? So here's the beginning of finding the answer is starting here, borrowing, okay? To borrow, what is to borrow? It's to take something somebody else has, right? And eventually return it to them. So let me have you two come up here. So let's start, before we really delve into the detailed answer of what's going on here, let's look at a basic situation that oftentimes is cited by different masters as borrowed force. If he's stepping in with a punch, so we're just going to have you do a basic combination, 3 combination, okay? Step in with a straight punch, step off line, block and punch. Now let's time that a little bit better so that now we have a situation where he's stepping in and getting hit. Heck, we could even make it easier. He's just walking towards her, taking a step towards her, and she strikes him in the face. Okay? Is that or is that not going to result in a greater force than if he's just standing still and she strikes him in the face? Well, I think we all know the answer. If he's moving into it, it's going to hurt more. That's common sense. But is she borrowing his force? Well, first part to finding the answer was here. What is borrow? I'm taking something he has. Okay, go grab your notebook. Getting cheesy here. He has a notebook. Okay, nice brown notebook, fancy notebook. I'm just going to borrow this. Now he's sad. But I took it from him and I can give it back. Here you go. I was just borrowing it. There you go. Okay, he actually had that. I could take it from him. Okay, you can put that back for a second. Now, the second part of the answer. Now we understand what borrow means. The second part lies here. For every action, there is an equal but opposite reaction. This is basically a statement of the nature of force. When she's punching him, he's hitting her. They're both, no, not, you don't, now there's actually 2 different sets of reaction forces in that situation. But when he punches, or when she punches him, there's a force that he's delivering into her fist. Equal and opposite. Okay, that force does not exist until the moment of impact. So the circumstance, him moving, there's something that changed that affects that force. But when he's moving, he doesn't have a force that she can take. It's not an innate property. There is something that is. His momentum. That's the difference. He's changed his momentum. Right now in this reference frame, in this dojo, he's not moving. His velocity is 0. His momentum is 0. Once he moves, he has momentum. Go ahead, move. Step in with a punch if you want, or walk or waddle, I don't care. But now he's not moving again. But when he's moving, if she impacts when he's moving, that's what she's tapping into there. Okay? All right. Now, so basically what we've arrived at is this is a misnomer. He doesn't have force that I can borrow. Although, there are a couple of circumstances where perhaps this term is a little more applicable. What if he grabs her by the lapel and now pull her towards you? Certainly there's a shared force there, action and reaction, but she can comply with that force. And there's another term I like better, which is purposeful compliance. But she can comply with that force and basically use it to help bring energy into her follow-up strike. Maybe do a 2-hand lapel grab, okay? And now check his arms and punch him in the solar plexus. Now let's do it again, but this time step with the other foot. Do it again, grab, okay? She can tap into that that force and use it against him. So if you want to use the term borrowed force, that would be a situation where it's more applicable. Okay? But when he's in motion, if another instance, people will say, let's say I kick you in the groin, so I now send you in the motion myself. It's still his momentum I'm tapping into. I'm not taking force from him because that force is something that's shared. Okay? Got it? All right, let's move on.